So let's move on towards the Tableau interface. So once you install the Tableau Desktop, this is the user interface that you will see as the home page of Tableau Desktop. What you see on the right hand side over here, what you see on the left hand side here is the connect pane. This is the place from where you can connect to various different data sources. If you observe, the very first option here is the Tableau server. But of course, this is only going to work if you have a Tableau server connection established in your organization. Let's cancel this for the moment. If you see the section below, you have various options to connect to different files, be it an Excel file or a text or a CSV file, even a JSON file or a Microsoft Access database, or even PDF or any statistical files. You have various options with respect to connecting to the files. All you need to do is select on the required option, browse for the required file and load it in Tableau. We will see how to load files into Tableau and establish connections at a later stage. Below this, what you observe is the various set of connections for different data sources which are present in the form of servers. Name a server and you'll find that in this list. Right from your Google data sheets up to your files residing onto the Google Drive, to connecting to the Amazon Web Services and to various Hadoop data platforms, you can connect to all the different data sources, establish connections and work upon that data in a live mode. I'll talk about the live mode in detail later. If you observe, you also have Microsoft SQL Server, MySQL as the commonly used databases available, to which you can establish the connection, load the data into Tableau and work upon it. But having said that, there are also some saved data sources or sample data sets that Tableau offers, which allows you to explore Tableau to a great detail. What we are going to work upon is the Sample Superstore, which is a database created by Tableau in order to help the end users explore Tableau to a great detail with the help of various types of charts and graphs. So let's click on this and you will see that this will load this page for you where all the visuals are going to get created. However, the very first thing that I would like to talk upon is the data source tab. So let me take you to the data source tab, and before even discussing what is this Tableau setup look. So this is the data source tab where you get to see the data that has been loaded into the Tableau environment, and you can try and understand various data related properties here. But even before we look at the data, let me tell you where do you get this data from. So when you install Tableau, it automatically creates a folder into your documents where all the files related to Tableau get stored. There is a data sources folder here, within which if you go to that current version, you will find the Sample Superstore related data that we are trying to access right now in Tableau. So if I show you what is present in this data file, this is a data related to a superstore which Tableau has created. So it's a dummy data. And if you observe, there are 3 sheets of data present in this file. The first one is the orders table, where if you see, there is all the order related details which are present, including details like your order ID, when was the order placed, when was the order shipped, various details related to that order, related to the customer who has ordered it, and also related to what was the revenue that was generated from that order. So there are a mix of various types of data types present here. If you see, there is alphanumeric data, there is date related variables, there are also geographical related variables where you observe country, city, state, postal codes, etc. There are also certain categorical variables which we have, and we also observe a lot of numerical variables here. So this is a good mix of data that you can use in order to explore the Tableau environment. Also, there is a people table here, where you observe that there are 4 regional managers who were responsible for managing the sales at the 4 regions. There is also a returns table present here, which contains of information related to the products or the orders which were returned. So all you see here is the order ID of the order that was returned and its return status as yes. The main table in this file is the orders table. So let's try to work upon these set of tables into the Tableau environment. So if I take you back to the Tableau window, this is what is present in front of you, where you can observe that same orders, people and returns table is loaded for you in this environment. Ideally, let me start from scratch. Let me remove this various tables that have been loaded here. So we have a clean canvas to work upon. If you observe the connections that we have been connected to, you can see that there is only one connection established as of now, which is the Sample Superstore, the file that we have loaded. Within that file, there are 3 tables: orders, people and returns. Currently, none of them are being used here. So it's a plain canvas and we are going to load the orders table and pull up the data here. So if you see, as soon as I dragged and dropped the orders table onto the canvas, you can see the entire data has been populated below. I'll talk more upon how to read and interpret this data. But for now, let me tell you that it is only the orders table that has been fetched here. What if I want to add more data? Let's say that there were certain orders that the people had returned, correct? So if I want to add the returns table also to incorporate that information regarding the products that were returned, all I need to do is drag the returns table and drop it next to the orders table. And this is where you can see that there are 2 tables that are now present. I can see the orders table present here. When I click on that, I get to see the details related to orders. And when I click on the returns table, I'll get to see the columns that are related to the returns table. Okay, so this is the returns table where we can see the return status as yes and the order IDs of the products that were returned. Now, this is where I have just pulled up 2 tables to work upon. But don't you think there is a relationship between the orders and the returns table? This order ID was also present as part of the orders table, isn't it? So we can actually combine these 2 tables together using an SQL join kind of operation. So how do we do that in Tableau is something that I'll be showing you. Let me remove this returns table from here. And now let me double click on this orders table. What does it say? Orders is made of just 1 table for now. Now this is where the orders table resides, correct? Now let's drag the returns table and drop it to the side of this orders table, and you see that immediately there is a join operation that has been performed. If you hover over this, it tells you that it is an inner join that it has performed on the basis of these 2 tables. The Venn diagram definitely tells you that. But if I do an inner join, what do you think will happen? Inner join will return us only those observations which are commonly present in orders and the returns table, isn't it? So this is where I will get to see only those orders that were returned and all the order related details for those set of orders. So if you see this table, I firstly see all the orders related data, and as I scroll to the right, can you see the return status and the order ID is also present, which came from the returns table. However, as I said, this is not giving me the entire glimpse of the data, correct? What I would ideally like to see is the entire set of orders, and for whichever products were returned, I would like to see their return status, correct? So that's where I can change the type of join that I have applied. So currently it's an inner join which has been applied by default. And I want you to observe that it is the order ID column which has been selected automatically because order ID was the common column that was present between both the tables. So order ID from orders and order ID from the returns table, wherever the records were matching, we had fetched only those set of records. But now I want you to change that join type to the left join. And as soon as I change it to the left join, what will happen? All the orders from the orders table will be fetched and the corresponding orders which were returned will be fetched from the right hand side table. So this is where I'll get the ideal data that I am looking forward to. We also have the other types of join, which is the right join and the full outer join. What will the right join do for us? If I select the right join, it will fetch all the returns that were returned. If I select the right join, what will I get? I'll get all the orders that were returned from the right hand side table, and only their corresponding order details is what will be fetched from the left hand side table. But this is not a complete data for me again. If I go with full outer join, I'll end up combining all the data together from the orders as well as the returns table. Correct? So out of the 4 types of join, we can either go with the left join or the full outer join in our case to work upon the entire data that we would require. I am going with the left join for now. Although it selected the order ID in order to join the data, as it was the commonly present column in both the data sets, but it does give you the liberty to select any other column as well. This wouldn't work in our case because we do not have any other variables in the returns table. But tomorrow, if you are working on any other data where the multiple tables are being combined, feel free to choose the column on the basis of which you would like to map the data. Let's proceed with this particular join and let's get rid of this window. So now that I see with the help of the Venn diagram that there is a left join that has been created between the orders table and the returns table, I am ready with the data. So let me close this window, and yes, the diagram here or the icon here indicates that it's a join table that we are looking at. So this is the canvas where you can drag and drop your tables and establish relationships between them. Now once the relationships are established, let's have a look at the data that has been pulled. Now if you observe this window here, this is the window that shows you the metadata associated with the variables. So if you see, you have the data type of the variable which is indicated with the help of various icons. You have the variable name given to you which is called as field name in case of Tableau. It also indicates from which table has that variable come from, and it also gives you any remote field name if at all has been associated with that variable. Now if you see, there are various icons related to data type here where the hash symbol indicates that it's a numeric data type. We do not have a concept of integer or float in case of Tableau. Numbers are just numbers. We have ABC to indicate that it's an alphanumeric data, so string data type. We have the calendar icon that talks about the date time variables. We also have a globe related icon that talks about geographical locations, and it is very essential to identify the geography related variables correctly in Tableau such that you will be able to plot the map related graphs and charts correctly. We also have some other variables here where you can see equal to hash as the symbol. This is an icon which is related to a calculated field. Calculated field is where we write functions or equations that help us calculate the values based on the rest of the variables. You also can create groups on the basis of variables where you get to see a paperclip icon. You can also bin the numerical variables where you get to see a histogram kind of icon. So there are multiple data types and various icons associated to it, which will help you understand the data as soon as you look at those icons. Talking about the header that you see for each and every variable here, these headers indicate 3 rows, where the first row of course tells you about what is the data type of that variable. The second row tells you about from which table has that column come. And the third row talks about the variable name. If you see, this is a button. So if I click onto this, you get to see the various other data types that I can probably use. So changing data types in Tableau is as simple as that. All I need to do is, let's say for example, if I want to change the ship date from a date time variable to maybe a string variable, I can just click on string and you will see that the data type has changed to ABC and the data got reloaded. Now this is where the ship date is no longer a date time variable. It's a string variable. Of course, I wouldn't want that, because if at all I have to perform any date related calculations, I wouldn't be able to perform them on strings. So let me change that back to the date data type. But I also want you to observe that in the country or region related variable, which was ideally a geographical location, you have several other data types that can be used. Currently it is country or region which is selected, but you also have airport. If you have airport names in your variables, you can select this as the data type. You also have city, you also have state and various other options which can be used in order to effectively visualize the map related graphs. This is very important that we assign the right geographical data type, because when the maps are loaded, we place the values on the basis of the latitudinal and the longitudinal information. And how will Tableau understand that? Through the right data type. So that's really important. If I talk upon how to change the variable name, all I need to do is double click on that variable and just change to whatever value I want to put here. So changing variable names in Tableau is also very easy. So this is the information that the header in the Tableau desktop displays. We also have certain other options here. If you see this drop down, this has certain options related to creating a calculated field or even allowing you to split the existing variable into multiple other variables. Let me show you an example. Let's say if I have the variable name as customer. Let me show you an example. Suppose I have this customer name as a variable, which consists of the first name and the last name. In case I want to split this into two different variables as first name and last name, we can easily do it with the help of the split option. At times, there could be multiple variables that could get created based on how many delimiters are present. So in case you want to custom split, this is how you do it. You click on custom split and you get this dialog box. This is where it prompts you to enter the separator on the basis of which you want to split. Let's say there is a space in the first name and the last name. So let me pass space as the separator here, and it also gives you an option to split off either the first part or the last part or all of the parts. You cannot unfortunately extract the in-between part of this data. Let me select all for now, given that I want to divide this variable into first name and the last name. Now once I click on OK, you will see that there will be two variable names, customer name split 1, which is related to the first name of the customer. So let me rename this to first name. Similarly, there is a second variable that got created which has the name as customer name split 2. this is the last name. So let me rename it to last name. Now if you observe, the data type associated with this variables is equal to ABC, which means that this is a calculated variable and did not come from the actual data file. So this is how new variables can actually be created on the basis of the existing data. Moving on towards the next discussion, this header over here tells you that there are a total of 29 fields having 12,620 rows for now. But by default, it only populates the first 100 rows in this window. So if you observe this area here, this is a text box which allows you to indicate how many observations would you like to see at a glance. If I set it to 1000, it will load the first 1000 observations for me. If I pass a larger value, that many observations will be loaded. However, it is not recommended to load all of the observations at once into this data view, because any which ways, we are not going to view individual records over here. We would rather prefer viewing this data in a graphical format, isn't it? So let's stick to the 100 records. Now, apart from this button, there is also another icon that you see here. This is the icon that allows you to sort the data. And this is going to sort your data at the data source level, meaning it will only sort your data to view in this window. It wouldn't sort the data in your database file, or neither is it going to make any changes onto the graphs that you have generated. This is just to view the data in a sorted manner within this window. So let's say if I try to sort the order date variable, one click will give me the ascending order, second click will give me the descending order, and the third click will again give me the data source order, which is nothing but the way the data was present in the file. So if you see, I can show it to you on some other variables. Customer name is what I'm trying to sort the data on. So one click, and then as per the ascending order, I see it starts alphabetically from A to Z. Now if I click on this again, it will be in the descending order where you will see the values are from X. Similarly, if I go as per the third order, which is the data source order, I'll again get to see the data as it is present in the file. So this quick sort icon is a very easy and approachable thing when you want to quickly sort the data for your own understanding in this window. Now, apart from this data view, there is this connection pane that I would like to talk upon. If you see this connection options, there is a live connection and an extract connection that is available. The live connection allows you to establish live connections with any of the data sources that you have been connected to. This is especially useful when you are connected to an SQL server or any other server where you know the data is going to be updated or refreshed by the database developers. So in case you want to pull that data and reflect those changes into your existing graphs and charts, it is required that you choose the live connection. However, the live connection slows down the Tableau environment a bit because it continuously keeps on looking for updates from the database server. That's where extract becomes a more useful option. Using the extract option, that's where the live connection is required in order to fetch the. Let's talk upon the connection pane. We have two connection panes, the live and the extract. The live connection allows us to establish live connection to the data source that we have been connected to, be it an SQL server or be it the Google Drive that you are connected to. All the changes that happen at the backend level will be reflected into your graphs and charts in a real-time manner. So whenever you want to continuously fetch the updates that are being happening at the data level in the graph level, keep a live connection established. This will help you reflect those changes immediately into your graphs and update them. But the live connection will unfortunately slow down your Tableau system because it will continuously try fetching those updates from the data source. In such kind of situations, the extract connection is a better option. The extract connection will allow you to fetch the updates, but at a periodic level. Only when you see this refresh button enabled, this is where it will indicate that there have been certain changes that have been made at the data source level. So only when you click on that refresh link, it will try to go back to the data file or the data source, fetch the updated data and load it over here in the Tableau environment for you. So extract will keep your Tableau system running faster because it will not continuously try and fetch the updates. It will only fetch it when you refresh it. So this is a better option than the live connection many a times when you do not want to reduce the speed of Tableau, but yet you want to keep on fetching the updates from the data. For now, I am okay with either of the connections because we are not going to make any changes to the Excel file. So let me proceed with the extract as the connection and let me take you to the next page, the most important tab, which is the sheets. It's asking me to save this file, but I'll cancel it for now. Let me show you this page of the Tableau interface because this is where we will be spending majority of our time throughout this masterclass. This is the sheet where we will try to work upon building the graphs. And let me tell you an interesting fact. Tableau has tried sticking to similar terminologies that are used in case of Excel. Majorly because the major crowd that was going to make use of Tableau were going to be Excel users. So the Excel users were going to migrate to Tableau, and that's where, in order to give them that comfort zone, Tableau tried sticking to those similar terminologies. So if you see, what we will be working upon is worksheets. What we are going to create as a file will be called as a workbook. And there are many other options and terminologies that you will see are going to be similar to what we have in case of Tableau, to what we have in case of Excel. Now, there are several menus here which will allow you to interact with the data. Starting with the file menu, if you observe, this is like our usual file menu where you can create new workbook or open an existing workbook or save your current workbook. And there is also something called as export as PowerPoint or export as packaged workbook. Now let me talk upon packaged workbook here. There are two versions of Tableau workbooks that you can create. One is a packaged workbook which is saved as a TWBX file with an extension as .twbx, because this is a file where you will be packaging the data, bundling the data along with the file to be shared with the client or with the user. Now, why is this required? Suppose I have built a dashboard which is present in the file which I want to share with an end user. Let's assume that this end user does not have the access to the underlying data. In that case, he will not be able to open that file and edit those graphs and charts because he does not have the data. That's where it is essential that I bundle the data along with the work that I have done in Tableau Desktop and then share it with him. So remember, that's where the .twbx extension is required. Whereas the other extension that you can make use of is the .twb, which stands for Tableau Workbook. This is where you can share across the files without sharing the underlying data with the user. This is probably useful when you are going to share the data within the team, because usually the team members do have the access to the underlying data. So there are two sharing options available in the form of two different versions of the Tableau workbook. Make use of them effectively based on your requirement. But as I said, Tableau does not restrict you to view the work that you have done in Tableau using only a Tableau related tool. So you also have the liberty to export it as a PowerPoint. This is where all your graphs will be converted to different slides in a PPT. However, one major limitation here is that PowerPoint will have the static visuals of the graphs. You will lose the interactivity that you get in Tableau when you export it as a PowerPoint application. So in case you want to utilize that interactivity at the runtime while displaying those graphs and charts to the users, I would always recommend to use a Tableau workbook and not a Tableau workbook as a PowerPoint presentation. You can also directly print it to PDF. So in case you're sharing it with someone who should be able to visualize it or open it even on mobile phones, you can directly share it as a PDF. Again, given that those images would be static, we would lose interactivity there, but at least the end user will be able to see what work you have done in the form of those visuals. So there are various other options and menus that are available. A lot of them are ideally disabled right now, but that is only because we haven't started working onto the data. Once we start working onto the data, all of these options will get enabled as they are applicable. We will explore more of these functions in the various menus at a later stage. But let me tell you one important thing. The help menu over here, this is where you would be able to manage the license. So if at all you have a license or a product key, this is where you need to enter it and you need to activate it. If you see, I am currently working upon a trial version on this system. Similarly, you also have an integration that is supported with respect to Python and R kind of tools. So if you see this option here, which allows you to manage the analytics extension connection, this is where you can integrate Tableau with Python or with RServe. Einstein Discovery is something that Tableau has come up as its own product. But given that Python and R are also tools that allow you to build predictive models, Tableau wanted to integrate itself with these kind of tools. The intention here is to build a model in Python and throw its visualization in Tableau. Now, of course, that requires a TabPy server, which you need to install on your system such that it can interconnect the Tableau and the Python environment together. Similarly, RServe is also a kind of server that will allow you to interconnect Tableau with R and integrate both of them. Apart from this, let me also tell you that there are various other options available with respect to formatting the data that you will be working upon, with respect to analyzing the data and working upon some quick calculations to be applied onto the various graphs. And there are certain other things that we will look at called as dashboards and stories. But even before moving on to dashboards and stories, let me tell you that you can sign in to the Tableau server from here. This is where you will establish a connection with the Tableau server such that you will be able to access all your data that is residing there and start working onto it. Apart from this, you also have Tableau public connection available from here, from where you can post your Tableau dashboards onto Tableau public cloud and it will be available on the internet. But as I said in the beginning, this could be a little risky given that your data will be publicly available. So use this mindfully. Moving on towards the dashboard and story that we spoke about. Ideally, sheets are the areas where you will be building graphs. However, there is only one graph that is allowed to be created onto each of the sheet. So we required a concept where we could actually collaborate those sheets together. And that's where they came up with the dashboard. So if you see this icon over here, the 4 squared icon, this is the icon that allows you to create a new dashboard. It definitely allows you to collate and store together multiple sheets such that we can visualize them at once. However, apart from that, it also allows you to add multiple objects into dashboards to make it more interactive. It also supports certain dashboarding actions, which we will have a look at later on, that will help you enable the filters onto various sheets together. The third icon that you see here is something that is related to creating a story. Now, what is a story? All the sheets and the dashboards that you have created in your file can finally be collated into a story, which will be the slideshow that you will present to the audience. So this story is nothing but like your PowerPoint presentation. The final thing that is displayed to the client or to the manager or any of the end user is the story, where multiple sheets and dashboards act like a presentation. So we will firstly work upon sheets, explore all the possible options on the sheets. We will then move on towards understanding the dashboards, where we will work upon multiple things related to dashboards. And then finally, we will collate everything together into a good story. That is how the flow of this entire masterclass would be. Now, talking about this left-hand side pane here. This is where you have two tabs, the Data tab and the Analytics tab. The Data tab is where you get to see the data that you are connected to. If you see, I am currently connected to only one of the data source, which is the Sample Superstore. But in case I am connected to multiple data sources at once, they all will be listed here, one below the other. From where do I connect to multiple data sources? This is the database plus icon that you see on the toolbar for it. If you click on this database plus icon, can you see we are again getting the same connect pane? We can choose whatever file we want to connect to, and that will be loaded over here to be listed below this particular database. Let's say, for example, I am trying to browse for another Excel file. Seems there is no Excel file in this. If you see, when I click on this database plus icon, I get the same connect pane which I got on the home page, which will allow me to connect to multiple other files. And whichever file I connect to will be listed here below this existing database. So in case you want to connect to different files and yet work upon them individually in this workbook, this is the place from where you can connect to. However, there is also another option that allows you to add multiple data sources. So at the data source level, if you observe, there is a add link which is present here. If I click on this, you can again see I get the same connect pane. But when I try connecting to any of the file from here, it will automatically try to perform a cross database join operation. So this option of adding the multiple data sources is ideally suitable only when you want to connect to data sources that are related to each other, where a cross database join would work. Otherwise, I would recommend you to stick to this icon, which will allow you to connect to other files but yet treat all your databases individually. Now, once I click on this Sample Superstore, I will be able to see all the variables that were present in that data source. If there was any other data source listed here, once I click on that, the variables related to that data source will be displayed. So it makes it very easy for us in order to access the required set of variables. The orders table here consists of various variables. So all of those variables are listed here. Whereas the returns table, if you remember, consisted of only the order ID and the return status. There were some other calculated variables which were present. So those are listed over here. And all the numerical variables you can see are listed here. So it divides all your categorical variables and the numerical variables with the help of this segment. Now, I want you to observe that there is something called as latitude and longitude, which has been automatically generated by Tableau. So because you had some location related variables which had the globe as the geographical location related data type, Tableau has automatically detected the need to have the latitude and longitude as the variables, such that you will be able to plot the map related graphs effectively. So this is where this auto-generated variables can be applied. At the same time, you can also see there is a count-based auto-generated variable that has been created. So when you want to visualize the data to see what was the count of total orders for a particular region, let's say, that's where this count variable can be handy. So Tableau does offer you a little bit of help. So this is where all the variables are listed, and from here I need to drag and drop them into this rows and columns as the shelves. I'm using some Tableau terminologies which you should be aware of when you are working into Tableau Desktop. So rows and columns are called as shelves, where, as I said, you will be dragging and dropping the variables such that you get to see their visualization in this view. So this area where you view the visualization is called as the view. What you see over here are the pages, filters and the marks cards. So these three are called as cards and they help you customize your graph. And this show me here is like a quick handy approach to choose or select the graph that you want to change the chart type to. So there are various options available here. I know currently everything is disabled, but that's only because we haven't started working on the data. Once we start loading the data here, you will see all those graphs that are suitable or eligible for that data will be enabled. And then you can change the chart type easily by just selecting it. Apart from this, there are also parameters that you see over here. These are like some workbook level filters that you can work upon. We will discuss more upon this advanced concept at a later stage. Apart from this data pane, there is something more that I would like to tell you about, which is the Analytics tab. This is where you see that there are several options which are currently disabled. This tab allows you to work upon a quick analysis on the data. If you observe, it also allows you to perform a little bit of predictive modeling. Yes, you can build a trend line, which is nothing but a time series forecasting model using Tableau. Tableau for now uses the exponential smoothing approach in order to build a time series forecasting model. This is the Analytics tab where you see several options related to summarizing and analyzing the data. The Summarize section gives you some quick options to insert different types of lines and to analyze certain values along with the group totals or the row totals. Apart from that, you also have the Model section where I would like to highlight that Tableau does offer a little bit of predictive modeling. It supports 3 different models for now, where trend line is the regression model. It supports different types of regression like linear regression, logarithmic regression, polynomial regression and some other types. This one will allow you to set a best fit line into the data such that you can understand what is the relationship between the data. The next one that you can see here is the forecasting model, which is associated with the time series forecasting. Tableau for now uses the exponential smoothing approach for performing the time series forecasting. And the third option that you see here is related to the clustering model, where Tableau uses the k-means clustering algorithm in order to cluster your data points effectively. And yes, there are some other options available related to fitting some lines or confidence bands into your data in order to make that data more business driven or insightful. So these are several options which again will be enabled for us as and when things are applicable onto the variables that we work upon. So now let's work upon building our very first graph. We will try to perform a very simple visualization just in order to see what all types of charts become applicable to it, so that we can try and test a few of them, and at the same time we will try out the customization of these graphs such that we will be able to understand how those particular options can be applied and the graphs can be beautified.
Like this video, subscribe to our channel and comment on the concept you want to learn next.